So this is a talk about what I call medium-end studies in computer science education conferences. My name is Michael Gerjoy. I'm from the University of Toronto. I unfortunately cannot be at Coley because they ran out of rooms, but I'm here in Toronto. You can get in touch. I have a Twitter/X account. So here's the outline. So what I'm talking about is what I call medium-end studies. So studies where the N, the number of observations, is large enough so that the traditional qualitative study is not feasible, but it's small enough so that the statistical power calculation would indicate that there is a large probability of a false negative, meaning a large probability where, assuming that actually you should reject the null hypothesis, you don't. So I'll briefly explain why I think underpowered studies can be problematic, and I'll describe what I call the Goldilocks problem for medium-end studies, where they're kind of stuck in between two paradigms that work better. So I'll talk about the current practice in computer science education conferences, calls for papers. So that's maybe a little bit distinct from the reviewing practices, but it's a start, I think. And I'll talk briefly about my thoughts about what might change, if it should change, if you think it should. So first of all, I want to categorize studies by just the number of observations. And I realize that that's not the only way to delineate them, but I think it's one way. So a qualitative study would be a study where there is a rich description of the observations. It could have as few as just one subject. So in some ways, one observation, with observation being defined not as like one single number, but what kind of one set of numbers that are all coming from the same source. So qualitative studies, I should acknowledge, can also be large. So something where you code a large number of survey responses is also referred to as a qualitative study. So something quite different would be an experience report. So an experience report would be just a report of what happened. So something that doesn't necessarily claim to be doing kind of science as traditionally understood, I guess, from a philosophy of science point of view. And in CSed conferences, an experience report would be sometimes referred to as like something separate from a research paper. And then we have a traditional quantitative study, which would be, in the terminology that many conferences use, a research study. So it would be a large number of observations. So the observations are like one or several numbers. Usually it could be other stuff per subject. So statistics, the discipline, is used to distinguish apparent trends that could be due to random variations from trends that still could be, of course, but look like they wouldn't be due to just random fluctuations, but would be due to genuine underlying patterns in the data. So ideally, not always, but ideally, power analysis, I'll talk about it more in a second, is performed, and the study is not underpowered according to the power analysis. Ideally, although again, not always, hypotheses would be pre-registered so as to avoid false positives. So, and then there are many studies, and I see many of those published in the past, and I'm sure in the future as well, what I call medium-end studies. So those are studies where the number of observations is not very large, and they're not, because of that, are not necessarily sufficiently powered. You see a lot of trends that are identified in the paper, so pointed out in the paper, but are not statistically significant. And sometimes that would be pointed out. Sometimes the p-value would just not be computed. And there's not necessarily a rich description of the data. So that's kind of just like my categorization. So what do I mean specifically? Like what kind of ends for medium end studies? So I'm just looking at, like I teach a CS1, CS2 class. So I have about 300 students. And from just my experience, an increase of 5 points on, a test or something out of 100 would be completely huge. You almost never see that effect from anything. In fact, if it ever becomes the case that I figure out a way to increase the performance of my class by 5 points out of 100, the school administration would come to me and say, like, what's going on? Not in the sense of, we think you're doing an amazing job, but in the sense of like, we think that your grading might not be great. And despite that, so despite the fact that I think in all of our experience, 5 points out of 100 is in some sense huge. If you think about it in terms of the Cohen's d, it's like a small to medium-sized effect, because usually, like, again, if we're talking about grades out of 100, well, so the standard deviation in usually what you will observe, like, say 15, something like that, it can vary a little bit. So 1/3 of a standard deviation. So if we assume that, so if we agree that 5 is a large effect, in the context of computer science education, although not in the terminology of Cohen's d, then we can just do a power analysis based off of that. So what do you need in order to have sufficient power to detect differences of this magnitude or larger? So if your n is equal to 50, your power is 0.2. Your power goes to 0.9 if you get to n equals 800. Now, a lot of studies have fewer than 800 students in the study. I think it would be fair to say many of them a lot fewer. So this is just kind of like a quote from Andrew Gelman. So Andrew Gelman, someone famously claimed to have never, ever made either a type 1 or a type 2 error. And the reason would be that, well, like a type 2 error is, the type 2 error is not really an error. So like a false negative is not really a thing. And then the type 1 error you can read by yourself. But there is a problem with underpowered studies. So a negative result will be interpreted as evidence against a scientific hypothesis. So even though technically people might say, well, technically you're just like failing to reject the null. Well, no, like people think about studies that fail to reject the null as, a negative result. Moreover, authors would often plot results or display results in the table without computing p-values. And I would say sometimes appropriately so, because you shouldn't compute a p-value if your study is underpowered. On the other hand, if you're not computing a p-value and you're kind of just suggestively displaying trends without computing a p-value, well, that produces false positives. So that's bad. So I would say that underpowered studies, at least without a rich description of what happened, seem like a problem to me. So what I'm arguing here is there is a bit of a Goldilocks problem here, right? So the study might be too large and also like not theory-based, and also maybe there's other considerations to really be a qualitative study, but it's still underpowered. So you can't really compute p-values or whatever else you want to use in order to get kind of solid results. So how do computer science conferences deal with this? And I should note, I have been a co-chair of a computer science education conference in the past, so of EWAI, involved with 60, although not with the research track. So I'm not kind of outside of this. I am trying to think about better ways to do this, and this is why I'm here. So here's basically my overview of all the calls for papers. COLI and ICER accept research papers, but not experience reports. And then 6C, TC, COMPED, EWAI accept research papers and experience reports. They make the distinction. In fact, the calls for papers are quite similar. And then COLI and EWAI actually recommend the 6 soft empirical standards as of this year, which I think, so 6 soft empirical standards is also something that I'm kind of actively working on, specifically in the context of trying to tailor them to computer science education as conference kind of context. So 6 soft list power analysis as desirable, kind of where applicable. So desirable as opposed to mandatory, but still. So I think basically the state of play here is there is this category of papers which reviewers might or might not kind of treat in this or that way, where yes, it is, I would argue, a problem, where it's not really a qualitative study and like not framed as an empirical, as an experience report, but the sample size is maybe not quite enough. And the power analysis was not done in order for it to be an empirical study that's not problematic in this way. So here's what I would suggest, and those are, I'm just a guy, so those are my suggestions. So I think power analysis should be required where applicable, because of the issues that are outlined before. I think underpowered studies, so studies where you have whatever, like 70, 80, something like that, observations, like I don't think they should always be rejected or anything. I just think that if that's the situation, then there should be a richer description of the data for the study to really be valuable, because the statistical analysis by itself does not really provide solid evidence one way or the other. I would consider thinking about qualitative studies, experience reports, and large-scale quantitative studies not as separate categories, but as existing on a continuum. And I don't mean like 1D, not like qualitative study, experience report, large-scale quantitative, but it's kind of a study can be a mix of those. And I think it should be, in fact, encouraged and possibly explicitly acknowledged. So the idea would be that every paper, it could be not a super large sample size. Well, in that case, the paper should be bringing something else to the table. And it could be kind of somewhere in between an experience report and or a qualitative study where you go more into details about what happened, and maybe you go more into detail about kind of how you understand the subject, and maybe the subjects, sorry, and maybe you have some kind of framework for analyzing the subjects. That would be great to compensate for the fact that that the study is underpowered. So email me, tweet at me. I'm happy to discuss this further and see where this can go.